Hi everyone, I am Hossein, and in this video I'm going to show you the difference between the stack memory and heap memory. I'm talking about recursion and stack overflow. Now let's see how a stack data structure works. In a stack data structure, we push a data and then the other data will be pushed on top of the previous data. Then the other data also stack on previous data like this, as you see, var num3. The order of push and pop of a stack data structure is last in and first out, or in short, LIFO. So this way, the last data that was entered will be popped out. See, the other one also, and then the other one. As we know from our previous video, when an application loads to the RAM for execution, it contains a code and data in a stack. So as you see in the picture, on top we have the code and in bottom we have the data that is stored on our stack. The point about the stack memory is that it is already allocated and there's no need for new allocations. So when we go, let's say, to a new method, that method will have its own scope of data, which is on a stack. The heap is different. For using the heap memory, we should first allocate the data and then use it. In our example, the loaded application into the RAM, we have some objects on our stack memory. For example, in here, when we new a player class, we create an object called result here. That result is a data on a stack memory, but when we new the player, that data that was inside a stack memory is only holding a pointer to the address of a RAM which contains the data of a player. And the same can happen for the student object. So now let's see how does it work in our example. Let me define a number, num1, and set 0. Then num2, set 10. Now I would like to say the result new that num1 plus num2. Now let's start our application to see how does it work. In here, as you see, we have our stack memory, which is located in here in locales. In here, as you see, the num1, num2, and result are all part of our stack memory. So I come down to here, you see, now the num2 is 10, and this guy, the result is 10. Now let's talk about a stack call, and it's a stack memory. For the stack call, let's assume that we have a function, void hello world. And in here, we're going to add int num10 and int num220. Now let's say console the right line, num divided by num2. Now let's start our application. Now we are in the stack call. In this tab, we can see on what stack call are we in. We are at the program main. And now here we shall call hello world function. Now let's start the application. There you go. F10, F10, F10. Before we go to the hello world, let's see what data we do have here. We have a result, num1, num2, and here we go. It's a stack call. In this tab, we can see on what stack call are we in right now. We are at program.main function, right? So now let's press F11. Now you see the main call stack is below of hello world call stack. Now I press F10. As you see here, we have a num and num2, and you can see that no longer the data of this level of a stack exists anymore because we are at this call stack. If I double click on this one, you can still see the stack data of this call stack, but for here, no, the data is different. I press F10, going forward, and done. Now let's see how Heap works. We write public class person, and then the public string first name, and then the public string last name, right? Variable person. Let's change the name to lowercase person, new person. Let me initialize this person first name by writing Hussein, person last name with Abdullahi. Now get full name, return first name plus space, and then plus last name. This one should be string. Let us start this. Now here we see that we have a person object. We have a person data here, but its value is null because we did not allocate any memory on Heap yet. But after I press F10 and we go and we run this line of code, we will have some memory on Heap. The memory on Heap is allocated and it has some properties here, which we're filling it. And in here, inside of our person class, inside of this object, the person, we have a data in our stack, which is this, which is the this keyword, which is actually pointing to the location of a RAM which we allocated for storing the data of the person object. See, it's the same thing. And in here, as you can see in the call stack, we've gone one level further to here. It is a good time to talk about two concepts in C#, pass by value and pass by reference. For example, in our hello world, if we give it a parameter called int num param and then change it here, let's say num param is gonna be 50, the value of this variable will be copied into this function. So let's see how does it work. In here, the num is 0, as we had the num1 0 here. See, the num1 was 0. Now in here, we have the num param as 0 because we copied the value of num1 and put it into the hello world. And then we changed the num param to 50, and then we can see that the value of the num1 didn't change because we were changing the num param, not the num1, and the num1 was passed by value. Now let's change something here. What if we create this person up here, and then we just give this person public int ID. Now let's put it here, person, pass it as a person, and here person is now 50, while before that it has a ID, the ID of 20. And here we're going to change it to person.id. Now let's see the result. We'll go down to here. The ID is 20, as you can see here. It has a 20 value, right? Now we'll go into it. Now let's see. The ID is 20. Come down. We have changed the ID to 50, you see? And then we come out of here. We're expecting that ID is still 20, right? No, it's 50 because we changed it here. And the reason that this one changed, unlike the num1, is because the object of person is passed by reference. Now let's see how recursion works. So in here, I like to say that ID is 3. In here, I'm gonna say while the person.id isn't 0, do this person.id minus minus, and then we say hello world. Call this one again. You see, we are calling the same function inside of that function. So let's see how it works. We start our application. We go inside of our hello world. It comes to here, says no, it's not 0. It comes one level down and then passes person object. You see, the stack is working. It pushed the hello world into the stack. We're coming down. The ID is 2 now. We're going one level deeper. And now we went one level even deeper. But this one says, oh, okay, it's 0. So I won't run this. We're out. See? We are out again. It's popping up. That's how recursion works. Now let's change this ID to, let's say, 10 million. And now let's run this application. I'm going to put a breakpoint here and run the application. You see, we got a stack overflow. It appears that it tried 16,000 times. It means that it went 16,000 times deep into the hello world, and the stack got way, way big, that it was exceeding the amount that was reserved by the compiler for the stack memory. So it couldn't just handle it and it gave up. Well, that's it for today. Thank you for watching. Leave a like if you like this video and subscribe to my channel and hit the bell so you will be notified once I publish my next video.